because, you know, as we estimate water resources availability through observation or through modeling, and modeling usually is applied to a single watershed, because we assume basically that water flows along the directions that we can guess from the surface. If you have water that rains over a catchment and coming back to a river in another catchment, this causes a misestimation, erroneous estimation of our water resources availability. So where basically they have the presence of karstic areas, they try to study them, how they work, and they use tracers typically. So they release tracers on the ground surface in a location, and we monitor where the tracer comes up in rivers. And sometimes they find that the tracer comes up in a different river. And this is the reason why they probably originated this approach and this systematic study of karstic areas in Switzerland. I hope this is fine enough. Another question, so you may move forward. Yeah.
Okay, my question is related to dams, because of so far we talked about that in the last classes. We know that most of the dams worldwide are built like 50 years old.
Yeah.
And so, just because we know that in those time, hydrology was neither a science, so we can consider that like a old hydraulic technique.
Yeah.
Okay. And so my question is, how today we should deal in a sustainable way with dams? I mean, it's better to destroy them, it's better to implement them with the technology like pumped storage, hydropower system, or either way, I don't know.
Okay. Yeah, first of all, the first thing to say is that, yeah, it's true that dams, let me see if I can just switch it off and then, it's true that dams were built when hydrology was not a science, but indeed the concept of structural mechanics and hydraulics that were needed to design a dam were already available at that time. So basically, I would say that that we don't have to be concerned about the reliability of the structures. I mean, it's not a structural problem. It is true that at the beginning they made some mistakes, and we know the results of these mistakes. And basically the mistakes were related to the fact that our understanding of geology was not as deep as it is now. And therefore, if you look at the mistakes, the reasons why some dams collapsed, at least in Italy, they were mainly, not only, but mainly geological problems. Not only because the Gleno, G-L-E-N-O, dam basically failed for a structural collapse and not for a geological collapse. But at the beginning, I would say that there was a problem related to the fact that the material that they used was not high quality. And especially the first dams were built in 1920, 1930 under the fascism in Italy. And also abroad, it was at that time that the first huge dams were built, like 100 years ago. So at the beginning was a problem of material and understanding of the geology. But already in the 60s, 70s, I think the knowledge was good enough. So from a structural point of view, I wouldn't say that it's a problem. There is a problem that is claimed. Some researchers say that there might be a problem due to the changing environment, meaning that the dams are equipped with spillways that are supposed to deliver downstream the flood flows. And some researchers say, given that the peak flows are increased for climate change, we are not sure that the spillways are still able to perform their function. I don't think this is a real problem, And it is debated, but it's not given a high priority, and I think that indeed this is not the problem. There is another problem, which I think it's a bit more concerning, which is aging of the material and structures. And this is also a problem for bridges. In fact, in the United States, they are becoming concerned. They already started a monitoring program for bridges and other infrastructures, not only related to water, because they are concerned by aging. And indeed, for dams, there are some dams that are still very, the storage is still very relevant. They are continuously monitored. So, they are not just left there to work alone. They are continuously monitored, and there is a law for that, and there are guidelines, technical guidelines. But still, I think we should start. So the concern is not a sudden failure. This is not the concern. The concern is that we have to think, starting on how to deal with these structures, because they are 100 years old, or in the best cases, 60, 70 years old. Typically their design lifetime was of the order of their age. So we have to start thinking about it, like how to deal with these situations, and also bridges. And keep in mind that for bridges, it's even more compelling because in most of the cases we don't know the foundations. So we don't have the original designs, the original projects, and therefore we don't know what kind of foundations they have. And therefore, basically, it's a structure that we don't know. And it's not so monitored. The dam is really continuously monitored. Bridges. So when a flood comes, you know that some bridges are closed. And why do they close only some bridges? Basically because we don't know how the structure is. We don't know the foundations. So if we have doubt, we are forced to close those bridges. But still, I think this is indeed a concern. And then there is another problem, and I think that you referred probably to that. Dams tend to have their storage reduced for siltation. At a certain point, and there are already some examples, they get completely filled. So how to do in this? What to do in these situations? So first. We made a lot of experiments about how to remove the sediments, and we also tried we tried flushing. Flushing means that you open the bottom discharges, and then you let water flowing for a long time through them. First problem, flushing creates turbidity downstream, which is really a disaster for the ecological environment, for the fishes, and also for the ecology. So this was a first problem. Second problem, so we realized that in most of the cases it's not effective. Basically what happens is that a canyon develops just in the point where the bottom discharge is. So you get this canyon in the sediments, but then the other sediments are not removed. So it's not such that you untap the bottom discharge and everything that is accumulated upstream flows downstream. It doesn't happen, just a small part of it. And so in the United States, they tried, and there is an active, this is an active field of research, they tried to remove the dams. So basically it's completely filled up, and of course you may take some of the sediments and to bring them away. This is not practical, so it's not doable that we redig the reservoir. It's absolutely not doable, because we are talking about like 100 millions cubic meters of material. So it's impractical to excavate it. It takes forever, and also you don't know where to bring this material. This is poor material. It's not a high value. So it's absolutely impossible. And so they tried to remove some dams. They just demolish them. And what happens is that the accumulated material starts eroding, of course, and flowing downstream. Again, problems for the environment. And it has to be carefully conceived because it may be also a danger for sudden landslides, things like that. And indeed, this is something that they are trying. In our environment, I don't think we have examples not yet, of huge dams that are completely silted. We have some dams whose reservoir is reduced, significantly reduced, but we still don't have urgent problems. But of course it is something that we have to consider. The dam is something that is not sustainable. It lasts for 100 years, 200 years, which is nothing. Okay, I would go in the row back. Do you have any question?
Actually, I want to know when is my presentation, because today I have a presentation.
Yeah. Okay, I think we agreed today, correct?
Yeah.
Yeah, and yeah, perfect. And it's tomorrow would be fine as well for you, or
Yes.
you prefer today?
Yeah, today is very good for me.
Okay, we can. You send it to me by email, okay?
Yes.
Okay, let me finish, and you don't have any question on.
No, no.
No. Okay, perfect. Let me finish this, and then we move forward, please.
Okay, my question regards a technique that I've heard of that regards the location of losses in the distribution network through satellites.
Losses in a distribution network through satellites, okay?
And I don't know how it works, if there are limitations or advantages.
Okay. You mean really losses, water losses?
Yeah.
Okay, I know, I try to be quicker in my remarks. I know that today there is an extensive use of satellites for monitoring environmental processes, and it's increasing. The problem is that we still don't know really how to take fully advantage of it. So I would like, for instance, to propose a research project for financing to the European community on how to move forward in this, because we have a lot of information, but it's still not clear how to use it. And regarding water resources, I know that there is a lot of interest in the possibility to monitor water levels from satellites in rivers and lakes. So far it works quite fine for lakes. For rivers it's a bit of a problem, because the problem with the river is that the resolution of the satellites is still of the order of 1 kilometer. It's not finer. And therefore, if you get a pixel in 1 kilometer, the river usually is not as large. For the lakes it works because you get the pixels of the satellites for the lakes. But there is an increase of interest in that, because the resolution of the satellites will increase. For leakages, water losses, I don't know anything. It's the first time that I hear of it. And I think that it may be related to the fact that they can, with satellites, measure the soil moisture. So, and this is something that is really working, has been working for about 30 years already, the research in measuring soil moisture. And basically what they do is, through the satellite, they measure the reflectivity of the Earth, and the reflectivity is related to moisture. When the Earth is wet, it reflects more. And therefore, I think that it may be used, the satellite, to estimate soil moisture around the canals and around the distribution networks in general. And where we see an increase of soil moisture, we may concentrate our efforts in that. In general, the identification of water losses is a topical issue. And in the distribution network for water supply systems, which typically use pipes, not canals, they use a lot of different techniques basing on sound propagation, they are really making a lot of research on that. And for the canals, we know that of course, there are leakages, but I never heard about it, but it's possible through the estimation of soil moisture. Okay, next one.
Yeah, actually, I didn't have a question, but I was thinking, what do you think, not what do you think, what do you mean to monitoring
Monitor a dam,
Yeah.
okay. Basically what they do is they monitor the structure through extensimeter. I'm not sure whether it's,
Do you monitor the structure or something else?
yeah, also you monitor the hydrology because you monitor the water flow beneath the dam. So we try to make the dam fully waterproof, but we don't succeed in that. We always have some water flowing beneath the dam and feeding the river downstream. And this is not concerning, provided the velocity of the flow is very small and the amount of the flow is very reduced. So what we do basically is, we know what is the water released by the dam because we measure it. It's the environmental flow. And then we measure the river flow downstream, close to the dam, close by, and try to see if there is an excess flow. If there is an excess flow, it's a problem. Also, the dam, even when it's made by concrete, it's not waterproof. So you get some filtration in the dam. And you can see it because the dam is equipped with tunnels. The dam needs to be seen inside. So by law, you need to make some tunnels in the dam in order to be able to.
But I mean, there are like sensor or.
No, you can just walk along them
Okay.
and you see water flowing from the walls. This water is collected and measured, and therefore, there are strict regulations. So if you see an increase of the flow through the dam, something needs to be done. And then there are sensors for the position of the structure. The structure continuously moves because tectonic movements, and also it moves depending on the water level. And all of these movements are monitored and in order to check that everything is fine. It's very nice, if you get an opportunity to visit a dam, it's very nice to walk along these tunnels because you are inside the body of the dam and you can really see that there is water from the walls flowing down. And this is collected, measured, and so if you have an opportunity, for instance, the Ridracoli Dam, which is the closest dam that you can see, huge dam that you can see here, and they organize visits for the public. If you get an opportunity, you should see it. And also the Vajont Dam, I already told you, if you get an opportunity to go there, and the visit is not very interesting because now it's not anymore open to the public. But you can walk on the top of the dam, but you cannot go inside. Only with authorization you can go inside, but still it's interesting. Okay, next question. Yeah.
My question is using the bottled water. My question is, for example, in the developed country, the using of bottled water is increasing.
Yeah.
Is it related to the quality of water, or is related to the sustainability related to the water supply? I want to know, for example, for the regions that there is water shortage, it can be a good substitute, for example, to the transmission systems or distribution systems or not.
Bottled water. Yeah, bottled, you mean. In general, no, it's not a substitute because, for instance, here in Italy, when there are water shortages, we bring water with trucks and tanks, but still it's not enough. The larger amount of water is not for drinking. The larger amount of water that we need is for irrigation and for other civil uses like showers, like flushing the toilet, like many others. And in general, water is related to sanitation. So if you have water, you can sanitize your environment. If you don't have it, it's a problem also for your health, not only because you run the risk of drinking not good water, but also because you have reduced means for cleaning. So,
because I have seen, for example, here, some people use the tap water.
yeah.
I don't know. So the reason of bottled water is related to the reason good quality of water here, or I don't know, it's related to the water shortage.
No, I mean, this is a different question. Let me finish. In the developing countries, basically, what is the reason why we encourage the use of bottled water? It's for drinking. And this doesn't solve the problem of giving water to these people. But if you give bottled water for drinking, you can partially resolve the problem by bringing water which is not high quality for everything that is not related to drinking. And to avoid the risk that they drink it, you have to bring bottled water. So this is a possible solution. Let's suppose that you have a problem of a village where the quality of the water is not good enough, or you don't have enough water. The solution could be you bring bottled water, which is quality water for drinking, and you have to strictly require that these people only drink bottled water, and then you bring water of poorer quality for everything else. And you know, also for washing ourselves, so we can use water which is poorer quality. And of course we have to know that, we don't have to drink it, etc. And this is a possible solution. So a mix, bottled water, and a mix of bottled water and water with poor quality may be fine. And this is also used, this is also the tendency here. The new houses, we try to recover water from the roof and use this water, which is lower quality water for flushing the toilet, not for washing, because also for washing there are some requirements. For personal use, personal hygiene, we can't use roof water. Of course, if you tolerate a little bit of a risk, like in developing countries, you can tolerate it because they are more resistant, and also you anyway improve the situation. You may introduce some additional tolerance. But anyway, the message is, even here we try to use poor quality water for uses where quality is not needed, like flushing the toilet, irrigating the gardens, etc. And this is one thing. And another question is related to our present situation and the quality of our tap water. Usually, in Europe, the quality of tap water is good for drinking. No doubt on that. And in some cases, it's very good. So in some cases, it may be good quality for drinking, acceptable, but not really the best of the quality, meaning that there might be a lot of, calcite, how to say, yeah, calcare, I think it's calcite. A lot of calcite, which is, it's not proved that it gives health problems, but still, it's not maybe not a good idea. And some people, even the medical doctors say, try to drink light water, because in the doubt that problems at the liver or at, I don't know, kidneys, really, are given by the fact that or may be alleviated by drinking light water, they say, okay, try to drink light water. So in some cases, our tap water is rich of calcite and also iron, which is, I mean, it's not unhealthy, it's not proven, but some people don't like it. And this is typical of this region. And in this region, when you use groundwater, it's rich of iron. And I think in English, I'm not sure iron is good in English. It's maybe something like ferrite water. It's rich of iron anyway. And you notice that because the sink becomes red. And as I said, it's not unhealthy, it's not against the law, it's not proven, but some people don't like it. Other people say that they are looking for iron because you know that iron makes you more powerful if you have more iron in your body. Some people take medicines in order to reach the content of iron in the blood. And some people like it. So I have some friends who say, I only drink tap water because I want to get more iron. So the result is that in most of the cases, the use of bottled water is a problem because bottled water is not environmentally sustainable because of the use of plastic. And therefore, there is, especially in Italy, in this region, there are the water boards who are making campaigns to convince people that the water that you can drink from the tap is in some cases higher quality than the bottled water. And indeed, you know, there are some bottled water. There was also some investigations by the law, by the government, because some bottled water, which is very cheap, sometimes without on its quality. And it's definitely less controlled than the tap water. The tap water is controlled every day. So the water boards are obliged every day to make checks. The bottled water is like every 6 months. And therefore there is absolutely no reason why the bottled water should be preferred. And again, there are several campaigns that are promoted for that. But not for saving water, just for saving plastic, for saving, and also, you know, for the benefit of the people, because they don't spend additional money for it. Okay, now, that being said, there are supply systems and supply systems, meaning that here, for instance, in this region, water comes from river water from the Apennines, from the mountains, and from the groundwater resources that are very clean. If you go in Florence, the water is definitely clean, the tap water, but it's the water from the Arno River, which is sanitized. It's a different story. So basically, at least, you know, psychologically, when I go in Florence, okay, I drink it, but you know, I know that it's water from the Arno River. So, and even here, if I knew that the water was from the Po River, okay, but it's controlled every day, sanitized, no problem at all. But still, it's not mountain water. And you can recognize it because also from the temperature, the water in Florence, even if you leave the tap flowing, it doesn't get very cold. And you know that in terms of drinking water, the temperature is an indicator of quality. So the colder the water, the higher the quality, definitely. Here, if you try in Bologna and you leave the water from the tap flowing, it becomes quite cold. And I have been in Vienna, and in Vienna it becomes really frozen. And they explained to me that it's because it's mountain water, and the mountains are just above Vienna, so it's direct flowing. In this case, in Bologna, it's mainly groundwater, which is good quality. But still, I don't think there is a good reason, even if you are in Florence, to avoid to drink it. Maybe, you know, in that case, so what I do usually, I get information. So when I went to Vienna last time, and I asked them, I went to an apartment taken with Airbnb, and they said, the water supply system, how it works, and they said mountain water. And then I tried, it was cold. So I drank it without any problem. And, you know, if you know that it's sanitized water, it's fine, because it's controlled every day, but still, I hope I replied to your question. What about you? Do you have any question? No question. Okay. So I